Okay, let's look at reflection. Second lesson in the light series for year 7. We want to look at the types of reflection, and there are two. The first one is called specular. Now this is where a smooth surface, like a mirror, will reflect the light rays and it will produce a clear image. So when we look in the mirror, we can see a clear image. That is specular reflection. Okay, so more about specular reflection. There is a simple rule that we need to know. Now, if we were at school, we would have done an experiment using a piece of equipment called a ray box. This is just a rectangular box which contains a light bulb, and at this end it has a very thin slit. So when we plug this in, switch it on, it produces a beam of light. And that's really useful for us for testing things like reflection. Okay, so what else would we have used? A mirror. When we draw these out, it's important you know this. We draw them, a mirror, as a straight line here with dashes at the back. So front of the mirror, back of the mirror, and it's known as a plane mirror. When we draw light rays, we draw them as a straight line. And all of this is done with a pencil and a ruler, okay, so keep it neat and tidy. We also put an arrow to show the direction of that ray of light. The other important feature we need to add is the normal line. Now this is shown as a dashed line, and it is always at 90 degrees or right angles to the mirror. Okay, so in your experiment you'd be asked to set up your mirror here, your ray box at any angle, doesn't matter, shine it onto the mirror, and then you'd be asked to measure the angle that the reflected ray comes out from the normal line. Okay, so you would measure the angle from this ray of light, incident ray, to the normal line, and then the angle of the reflected ray. Okay, so let's look at that in a little bit more detail. So you'd use a protractor and we'd measure this angle. So for argument's sake, this is 30 degrees. This ray of light is known as the incident ray. Okay, and sometimes you'll see a little eye is used for that angle, but when we measure it, we actually have a figure there that we could put in our results table. We then observe the reflected ray, and we would draw that onto our page. If you imagine this is sat on our book, so the board would be our book, we would draw these lines on. And then we would measure this angle here. So this is known as the reflected ray. And we would measure this angle here. Now if this angle is 30 degrees, this angle will also be 30 degrees. And that's angle R. So lowercase I and lowercase r. Okay? And the rule is that the angle of incidence here always equals the angle of reflection. So in the experiment you would move your ray box out and have a bigger angle, 40, 50 degrees, and the reflected ray will always be exactly the same angle. Now if we shine our ray along the normal line here, it will reflect back along the same path. Okay, that's the only exception to this, although the angle of incidence and the angle of reflection are still the same, they're both 0. Okay, so that's the experiment you would have done, and if you've got any equipment at home that you might be able to use with a simple plain mirror, have a go and look at that yourselves. Okay, what do we see when we look in a mirror? This is quite confusing at first, but again, try it yourself, get yourself a plain mirror and have a play with this. So what have we got? We have an object here, the letter E. Just imagine that's on a wall, okay? This is the mirror here, and we are looking into the mirror. This is our eye. What do we see? We actually see the E, but it's back to front. And that is an image, because it's not real, it's virtual. So, how do we construct the diagram? We draw the rays of light coming from the top and the bottom of the object, and they strike the mirror here and here. We've got normal lines which run through the mirror, and then we try to get the reflected rays here which go into the eye at the same angle as the incident ray. Now when we look at the mirror, we actually see the image here. So it's equally behind the mirror, but it's back to front. So if we were to use a mirror, let's see if I can get this to work. If I put the mirror here, you can see, hopefully, that we get exactly the same image. So have a go at that at home if you've got a mirror. Writing in particular is quite useful because it is back to front. We want to look at diffuse scattering. So if you take a piece of paper, we can see this piece of paper here has rays of light shining on it. However, these don't reflect off all in the same direction to produce a clear image. They scatter the light. So these reflect, so it's a type of reflection, but it scatters the light, so there is no clear image. You can't see any reflection or image in here. So this is known as diffuse scattering. The rays of light from our object get scattered in different directions, so no clear image is produced.